Welcome to Inflection Points, a podcast about change in tech, hosted by Allie and Brendan Bonner, and brought to you by the Office of the CTO at Extreme Networks.
We see a world where people have become infinitely distributed around the globe, which means businesses must work at scale and focus increasingly on becoming consumer-centric to connect with every one of them.
Hi, Brendan.
Hi, Allie. Welcome back.
Welcome back to you. How are you?
I'm doing good. It's kind of we're coming into summer now, so everyone's starting to perk up a little bit. We're seeing a little bit more sunshine, but that's all the real world. I know today we're going to be talking about what happens in the virtual world. So, So are you looking forward to this one today?
I am. Yep. Today we're going to be talking about digital twin technology, which I'm really interested in. I think it's really exciting. It's another one of those technologies that we are right on the cusp of it being everywhere, I think. I was doing some reading this morning. I saw an article that says, we expect digital twin to be like a $65 billion market within the next 7 years, which is wild because 6 months ago, 10 months ago, I hadn't heard of digital twin. So what do you know about this?
Yeah, I'm on the other side of the spectrum, and we're kind of in the same boat. So for the last 10 years, it's been talked about in manufacturing. I think it goes all the way back to NASA trying to launch spaceships and Rolls-Royce trying to make sure engines don't fail. And every time something new comes up, we're thinking back, okay, it seems to be a good idea that this is going to be the real kickstart of Industry 4.0, Industry 5.0. But then you're thinking, yeah, I've heard it before and it's never really come to fruition, or else it's been done somewhere in the background that we don't really get to see in our day-to-day jobs. So I'm hoping we get a bit more visibility and to see whether or not it is just a hype, or is it a technology advance that we can start to sort of bring more and more people on board and start to see more data, more sensors, and creating these new manifestations of ourselves.
Yeah, that's right. The idea is there. The idea has been there for a while, but are we going to be able to implement it in a cost-effective way that it becomes transformational? And what are the use cases? We've thrown out a few, but I'm sure there are more that I want to learn about and get into. So Amy Cameron is a research director at STL Partners, where she works with world-leading operators and tech companies to really define opportunities and strategies for growth and innovation. So she has a particular interest in digital twin technology, and she is here to talk to us about it today. So welcome, Amy.
Hi, thanks for having me. It's great to be here. Always good to get a chance to, bring the stuff that you write about in reports out into the real world. So work a lot with telecoms operators and other tech companies, and we look a lot at all kinds of different technologies that are coming to market. But just as you were saying, Brendan, that digital twins are, sort of coming to the forefront again. They're also sort of coming on the radar of telecoms operators who are thinking about how they could adopt that technology for their own operations or potentially for their customers.
Can we start with a broad definition as best we can of how we would describe a digital twin or digital twin technology today, even though, it is evolving, it will probably continue to evolve. But today, if we were going to define it, what is it?
Well, I think that the definition that we're using at STL Partners, and that we're, differentiating an AI model from a digital twin is that it is a real time representation of the asset that it is linked to. So one, it's more real time, so it's actually replicating what that asset is looking like right now. The other thing is that it is specific to that particular asset, right? Because when you're looking at an AI model, for instance, it might be like a general model of customer behavior in, a certain retail environment or, relating to a certain, type of service. But a digital twin is like, I am doing a twin of this particular cell tower, of this particular piece of manufacturing equipment. And so it is tied to a specific asset. And I think that that is really important. The other thing is that it has a full historical view, right? So it has the real time data, but it also has, what's changed over time for that particular asset. And that there is a two-way interaction between the physical asset or the physical process and the digital twin. So, not in all, you won't be doing it in all instances, but if you execute a change on the twin, that could be sent back to the physical item. And I don't think that's always the case, but it is a two-way interaction is possible. So I think those are some of the things.
Yeah, is that the big difference? So in the past we had things such as simulators and emulators, which simulate the behavior of something in the best case scenario. And then on the other hand, you've got AI models which try and predict something by learning and continuously improving themselves. Whereas with digital twins, is it where we're taking that real world information and continually using it to relearn behavior so that it replicates not in a simulation, but in a mixture between using AI and machine learning and real time data to be able to give some prediction of what exactly would happen if something very pertinent happens right now. As in, if you move a robot arm and it's going to need really ultra sensitive touch feedback, you really need to be able to have a digital twin rather than just a prediction to say that this is going to break some component on a manufacturing line. And that's really where we're getting into. It's preventive, it's non-reactive based use of AI for the betterment of improving a process. That's very general, isn't it?
Yeah, well, I think the way that I see it, like, when you have these new technologies, like everybody sort of visualizes it and understands it slightly differently, which is why we're having this conversation. But the way that I see it is that it's because it's linked to the actual real world asset that makes it different, right? Because if you have a generalized AI model and it'll say, for instance, if you take in telecoms, like if you shut down this cell site, then your traffic is likely to be redistributed in this way, because that's what we've seen happen in the past. Whereas if you're using digital twins, you're saying if we redistribute, these are the exact parameters of these exact assets, and they are going to change in this exact way when you implement this change to their configuration. And it's not like generally this is how radio access networks work in telecoms. It is specifically this radio access network, this cell site, which is configured in this way. You can tell how it's going to be impacted because you're so specific to that particular item, and that enables you to make better predictions. But I wouldn't discount the simulator aspect, right? Because a lot of the time you are simulating, like, this is my real mobile network, this is how it is set up, this is how it is configured, and I want to see, like, what happens if I have this weather condition. If I have a natural disaster that cuts out half of these cell towers, what is going to happen? And so you're still simulating, right? You're not actually going to cut out connectivity to half of your towers, but you're looking at, like, what will it actually look like in this particular environment, where
Hmm.
that's likely to happen in the southern US or something.
Right. And then you also have the ability to, if you want to, when you
Yeah,
want to,
yeah,
push those changes and replicate those changes in the real world environment. So it's not a
yeah,
snapshot necessarily. It's like you said, real time. It's interactive, but it's also you can the environments are connected in a way that
yeah.
a strictly simulator type AI environment would not
Yeah.
be.
Look, and there's like positive ways that you would use this, right?
Yeah.
I've just used like a negative example that you would simulate for a rainy day scenario, but you might sort of be thinking about, how can I make my network more energy efficient? And you know that you can shut down, you know, this 10% of cell towers, and this is how we'll behave under traffic conditions, for this particular network. And obviously that's a benefit, right? Because you're saving energy, while delivering the same level of customer experience. And that's something that you would implement in practice, and you would have visibility into, like, how that's going to impact that particular part of your network that you have a digital twin of. But I think that, just to be clear, to be honest, there are not very many, or even I'm not sure if there are any, digital twins of actually, like, a cluster of hundreds of cell sites. I don't think that exists yet.
So it does sound computationally expensive as well. Do we have to be very focused in where we're approaching digital twins, where simulations would be done in planning or being able to try and assess whether something like, okay, there's a storm coming, I need to start assessing the impact, whether it's going to be on a city or whether it's going to be on a network. So is it going to be something that's going to be very niche, or can you see it become more widespread?
I think realistically, it's going to be pretty niche to begin with because there is so much computational power attached to it, like particularly all that data. Like you got to store it somewhere because you're keeping the historical data. There's a lot there, and I know. Some industries obviously have a little bit more cash to spend. Telecoms is trying not to spend so much cash. And so they've got to be careful about where they make their investments. And so the areas where we're seeing it most is really in deployments of telecoms networks, right? So if you're expanding your 5G network and you really want to make sure that you're getting the best bang for your buck. For instance, what Vodafone has done in the UK is it has um, a digital twin of the um, geographical environment of all of the UK and sort of what buildings are where are their trees and how do their leaves grow in the summertime and all of this kind of stuff that gives them a really accurate picture of the geography in which they are deploying their networks, and that makes helps them to make really good decisions about how to position any new towers that they are setting up, um, to make sure that they're getting the best bang for their buck. And so that's
No, no more finger in the air.
Right.
Yeah.
exactly, exactly. And so those are some of the earlier implementations, and that works well partially because there are these, mapping systems where a lot of this data exists already. It is available, it is accessible.
So we're at the end of the industry 4.0. We've got lots of data, which is what we were trying to use to build these models. And we've started to see people being very interested in the outcomes of both a visual digital twin plus a, a theoretical digital twin as well. So within smart cities, or if you're monitoring networks in a stadium, for instance, you can tell when there's a surge and when there's not, depending on when the players are on one side of the field or another. So there does seem to be lots and lots of potential, but I think they're just calling it digital twin, or is there genuinely something new?
Well, I think one of the things that is new and that has the greatest potential is this idea of um, sharing data beyond today's silos, right? So data today, it lives whether you're inside a company, it's your data is probably siloed across different parts of the company, or there's silos between companies, right? Like it's not like most data that enterprises have, they're not sharing externally because it's sensitive, because they don't know whose hands it would get into, because they're worried about security breaches. There's lots of reasons why you wouldn't share that data, but there's a lot of pieces of that data which you might be willing to share if you were clear of how you could do it, who was using it, you could control the access parameters. And I think that's part of where the real value is, because you might not want to share data directly from your asset, but if you had a digital twin which is once removed, you can use that as your sort of device from which you share information outside of the four walls of your organization. And I think that's where you get lots of interest. So, a lot of today it's very common to like pull in like weather data as a third party data. But what if I could pull in some information, I don't know, from like one of these like
Traffic
traffic
conditions or
conditions or
stock
stock
market
market
changes?
changes, or but also things like, all the e-bike companies, and maybe they have some interesting data that they might share publicly with others, or all these delivery systems, the UPS trucks that are all censored up, maybe they have some interesting data that could be valuable for smart city planning. And that's not easily accessible, and there are companies that are looking into using digital twin technology to sort of control those security and access parameters. And I think that's really where you get to see some new business models, some new insights by combining other data sets. And that's really, I think, what lots of people had envisaged in the value of the internet of things, which no one is really capturing very effectively yet.
Yeah, lots of data swamps and not a lot of
Mhm.
outcomes.
It's really interesting.
Exactly.
Let's talk about the smart city planning for a minute. What I mean, how what are some of the applications of digital twin there? Assuming, we get all this data from multiple different data sources, what can we do?
Well, I mean, I think that one that's very top of mind in the UK and in London is things like, how can we adapt our transportation system to lower air pollution, right? And understand the impact of air pollution on health. And so I think that if you had, much greater visibility in terms of, where those pockets of pollution were, what is contributing to those pockets of pollution, what solutions have worked well in um, other cities or other parts of the city, then you could apply that to make it better. So, I think that this is something that affects every city, to be honest.
I'm guessing, Amy, as well. Do we have a proper understanding of who needs to be in charge of this? So not so much in charge, but to be able to understand the needs. So we're talking about lots and lots of data sources, and we're trying to make some sort of business decision. Let's say the objective is going to be improving the quality of air within a city. So traditionally, and just out of interest, Ali, as well, when you're doing that smart traffic planning as well, it's almost identical in the telco world as well, because it's all about how populations behave in a limited number of resources. But then you have to really understand, okay, the behaviors of people to be able to do proper planning, as in to be able to make changes to the network as you go along. And I guess it's similar with smart cities, networks, everything. We need to be able to take a step back and go a little bit higher and say, okay, it'd be more interesting to get the health data, it'd be more interesting to get the weather data, the traffic data. So, do we have people that are trying to pull these big models together, or is it very much okay? We'll build it from our local needs. So, a city will need to reach a certain ESG target, or a network will need to have capacity to make sure that everyone can use their phones and upload all of their 5G pictures in the event of a coronation.
I mean, in my opinion, some of the stuff that we've been chatting about just now is much further in the future. I think that we've got to figure out the implementation on much more discrete use cases first, because if dial all the way back, right? Digital twins, big in manufacturing. We're at the very beginning of thinking about it in telecoms, where there are equally complex and valuable assets to be monitoring, and simulations that could be quite valuable to run. I think the more you get to a multi-stakeholder environment, the more complex it gets. And I sort of feel like, you know, in our research at STL, we propose all kinds of stuff that could be helpful, and you need somebody to bring this all together. But it always comes down to the business case is really difficult to make. And I don't think anyone's really in the position to make a strong business case for this now. We know that governments don't have a lot of money to spend on tech development. Well, not in smart city planning anyway, more in defense.
I do think as well. I mean, there's obviously going to be some more critical ones. So when we talk about, let's say, heart surgery, I think that was one direction for a surgeon being able to simulate things before he actually goes in. You can tell that's kind of critical. Now there seems to be a spaceship launch every couple of months or so, launching tens of thousands of satellites that have to all coordinate together. And if anything goes wrong there, we've seen Gravity, we've seen movies. It's catastrophic, and it's very important that you have some type of beyond simulation. So is that where the investment's going to go? And we're just going to hopefully over the next 10 years take the best learnings of those mission critical services and apply them to other industries.
Yeah, I reckon there's going to be a lot of experimentation, and it'll become more and more mature. And I think that one of the questions is, because coming all the way back to the beginning of the conversation, is like, is this something that we're going to see explode, or is it something that's just going to sort of tick along in the background? At the end of the day, like, most people might not see digital twin technology, right? They'll just see like the end benefit that's there, right? So some of the interesting medical examples that I've seen are things like, they are doing like a digital twin of parts of the human anatomy, like the human immune system or the brain, in order to test potential treatments. And obviously, like some of the scientists doing this, they're going to see, some visual representations and like, see how different things impact and like look at that over time. But as a patient, we're never going to see that. Like, we're just going to know that, this thing that was really difficult to treat is now easier to treat.
Right. Is there a future where digital twin technology is more um, directly tied to patients in healthcare or other applications of digital twin in healthcare?
Well, I mean, there's the other one where it's like, should I have a digital twin of my body and understand, like, okay, let's have a digital twin of Amy and, she gets sick and like, let's test this medicine on her, or, I'm diagnosed with some rare disease and there's a cocktail of medicines that I could try and like, let's put that on my twin and see what happens. But I feel like that's pretty far away in the sense that like that would be really expensive to do and honestly like I don't even know how feasible that is, right? We don't know how the brain works. Like we don't really understand our physiology to the full depth. So like how well it's not the same as like I have built this jet engine. I've created all of the components. I know what all of the components are. I know what they are all supposed to do. I know what I'm measuring and what the sensors are telling me. That is really different than trying to create a digital twin of someone's physical anatomy that we don't really understand the science of. And so it might be much more simple, like our the when you start talking about things in the healthcare setting, that we don't fully understand.
Yeah, I guess we will see sort of more accessible ones. Well, we're not getting a simulation to say, okay, this is what your health's going to be like in 20 years time, so walk with a different shoe. This sort of thing is probably too big, but there are areas such as personalized medicine and some genome treatments as well, where we understand the model enough that we can apply a digital twin. And again, what you would like to see is that visualization of this. So I guess what we could do as well, we're working on the science for the big numbers for the predictions. Do we need to just keep improving on the AR VR element of it to make it visually attractive?
I think it depends a lot on the person. Some people like AR, VR stuff and some people don't. You can see, like, I think that's just one way of representing it. Like, sometimes you don't need the visual representation. If we go all the way back and think about, like, a telecoms network, if you were doing a twin of a large scale network, like, you just can't visualize the thing. It's too big, right? Or whatever, you could visualize it and then you'd be focusing down on certain parts of it. But there are obviously places where it makes a lot more sense, where you're thinking about like, I have a doing some like collaborative engineering and there are two experts who are on opposite sides of the world and too time poor to travel to be near to each other, and they have like an AR visualization in front of them and they're moving stuff around and like testing stuff on the digital twin to simulate what it would look like on the physical asset, whether that's an F1 car or some new piece of manufacturing equipment that's being developed.
Yeah, are they too closely aligned at the moment? Because when you talk about digital twin, and I've been lucky enough to follow some of your pieces and some of the presentations you've given, they all seem to have that visual element. So whether it's network planning, let's say spectral planning for radios,
Hmm.
or any of the ones like a smart city, they've got the technology which does the predictions in the background, but until it's shown in a headset that you can see someone walking around in this simulated world and being able to interact with it, it doesn't really seem to get a lot of traction. Do we need to detach that or bind them closer and get people really interested in thinking they're really cool technologies to work in, and that's how we get the investments?
I mean, maybe. Like, I don't know, maybe it depends who you're speaking to. If I was in a telecoms operator and trying to convince the CFO that we should make this investment, I'll probably show them the numbers. um, but if I was trying to convince the the CEO, maybe I'm sure they're numbers people as well, but they might be moved a little bit more by having the visual representation. But I
Nah,
guess
they like graphs.
they like graphs. They like graphs. Yeah, I mean, maybe on an individual level though, because we always know culture is always the biggest thing. It's always the hardest thing to get people to take up a new technology and build it into their day to day. And I'm not convinced that digital twins are ever going to be a big day to day part of a large spectrum of people in a telecoms operator. Um, but it might get some people moving.
Yeah.
We're excited.
Let's think about security and how security is important in digital twin technology. I mean, is that one of the constraints, do you think, to widespread use or widespread adoption, or just how do we consider that when we're thinking about this?
Well, I mean, I think that actually it's one of the widespread applications is understanding the security risks. So another thing that you might simulate is what happens if I have XYZ type of attack on my systems. And so I think that that is actually a real value of having a digital twin because it can really understand where your vulnerabilities are. And so I think it's, really valuable from that perspective. I think from the other perspective, in terms of the the risk, I mean, that risk is there with everything, right? Any data that you have, any mission critical, any critical system that you are running, you're going to have a massive security risk.
Are there underlying technologies that we need to see further developed before we see more widespread use of digital twin technology, or are we there?
Well, I mean, I think that one of the things that you do need is you need to be able to access those different sources of data. And the telecoms industry has made real progress in this over the last 5 years in terms of getting their data and estates in order and, good governance in place and, having data pulled together from different parts of the organization. But I think that just like with any AI related technology, it all comes down to, do you have clean, reliable, real time data streams that you can feed into this analysis? And so I think that that is definitely one of the barriers um, that sort of needs to be in place beforehand.
We
Yeah.
do know it's going to tell us whether an engine's going to fail in the spaceship, but it's not going to come out with something random based on based on this digital twin. I'm going to tell you whether or not Allie's going to have to drive a little bit longer on her route home from work. So
I don't think the digital twin is doing that at the moment. No. But I, Ali is also not doing, I mean, the digital twin is not doing all of Ali's background research for today's podcast for her. I'm not saying that ChatGPT did, but it could. I mean, maybe
Kind
I
of.
had short prep time today. Maybe I should have chat GPT'd that.
I know, I know. I'm thinking I
We've all
made some
missed the trick here,
mistakes
guys.
and
this is the ethics question we all have. Yeah.
I mean, I think some of the other things is, really what I mentioned is before is adapting the technology into new environments because, you can't, there are some instances where the application of digital twin in manufacturing will look quite similar to telecoms, but there are other instances where it will look really different. Um, for instance, one idea that one of my colleagues had, which is very forward looking, but is like, let's use the digital twins to map customer behavior of our customer pool and use that information in order to do like better product planning. And that's like a completely different having a digital twin of an engine or something, and you sort of understanding just, do you need the same technology? What does that visualization look like? How do you use it? Who needs to use it? What systems does it need to integrate with? Like it's a whole like right now it's like an idea which maybe could has legs or maybe has zero legs.
I guess related to that as well is, okay, what feedback are you getting from people who you talk to? Because they're the ones with the problems who are coming to us and saying, can you apply digital twin technology to this? They get excited by it. the same as when we talk about A or V or AI. But is there? I know we were talking about the 10-year time frame for when it becomes kind of large models and they're able to do more prediction. But what's the current? Let's say if we pick an industry such as networking, what level of digital twin has been applied to that? Do they use it for planning? Yeah.
Really experimentational. So, if you look around the industry, there are only a handful of examples of, real stuff going on in telecoms operators. And I think that some R&D teams that are developing new services are experimenting with the technology, but it's really at the stage where it's like, let's make the business case for this. Let's understand, why it can deliver a return on investment. Let's experiment in this particular area, see what our return on investment is, and then think about doing something else. And they're still in that early phase in my perspective. So there's a long way to go.
Amy, we talked earlier on about the applications of digital twin to networking. We've talked about its history in manufacturing and in engineering. But can you see in the short term, is there going to be other industries that are going to be the go-to place when we talk about digital twin technology? Is there other industries that are really saying, okay, this is something I'm really ready to bite on outside of manufacturing? Because we can see Industry 4.0 is going to continue on their cadence, but there has to be other industries that are going to be taking this off the shelf and saying, I could use this.
Yeah, well, I mean, I think the way that I would think about that is, where are the industries where there are some complex, high value assets that are at risk of failure, and where their failure can cost a lot of money? And you can think there's quite a few industries that, fit this context. Maybe you'll be thinking about mining and oil and gas, where they've got some pretty heavy duty stuff to monitor, and it might be good to be able to monitor that from a distance. So those are a few others that I would highlight.
So, thinking about long term, 20, 30 years out, what does this technology look like? What are some of the applications? Let's imagine for a minute where digital twin is.
Yeah, I mean, I think it could be a technology that is leveraged to underpin, a more Internet of Things environment, where you have like, a more automated environment, right? Where you have twins of assets across different companies that are trading information and executing actions based on that information without humans ever getting involved in that. And they're using the twins because they offer an additional level of security and visibility that is not possible with the way organizations share data today. And so I think you'll just see like a lot more efficiency and automation happening in the background. And hopefully, delivering good results rather than nefarious ones for us.
Yeah, I mean, as well as that, what do I need to do to get ready for this? So if you imagine in 10 years' time, I'm trying to train up people now to try and be ready for the digital twin. Should they be trained in arts or should they be trained in science? Is it going to be a very data specific world, or is it going to be something where we have to have people coming up with these ideas to say, okay, this is how it will improve your life?
Yeah, I
I'm
mean,
very optimistic, by the way, about digital twins.
I think that you need people to be creative, to be able to understand, like, think laterally about like how can this technology be applied to solve a problem. And so you have to understand the technology itself, but actually you don't necessarily need to understand all the nitty-gritty of how this stuff works. You just need to understand like what's possible and what's the limitation, and be able to apply that to your area of expertise, whether that is healthcare, whether that is running a telecoms network, whether that is, planning a city, or whatever it is. And so I think that you do really need those combination of things. But I think the creative aspect will be super important. And that's when that's kind of like, maybe difficult for AI to take over, because it just learns from the past, right? It just learns from what it's seen before. And, the best creative brains think about something completely different. They think about something completely new. And AI can maybe help with that a little bit, like in terms of, trying to apply something that's happened in one industry to another. But I think humans um, probably can be better at that than machines for quite a while.
Yeah, so we still need to guide them. So it's when the digital twins start talking to each other, then you'll have new use cases and more benefits. Well, hopefully all benefits.
Yeah. Well, I guess they're also just, sort of understanding like what is the underlying technology that made this result possible. And then being able to sort of think laterally about executing a similar impact in a different area. I'm not giving enough specifics. It's not my job, guys.
I have one last outlier question as well because someone brought it up today. So will blockchain and DLT technology, will that play any part? Because one of the things you mentioned earlier is you've got large pools of data and you need to be able to expose them and share them. So can you see a technology based on blockchain being part of the digital twin creation of this new world in 5 to 10 years?
Yeah, I mean, I think that one of the exciting elements here, I mean, despite a lot of bad press over the years, is blockchain's ability to do transactions. I think is definitely valuable. Look, like, not necessarily the way crypto's been deployed today. But I think that that is one of the things is that, if you want an incentive for selling your data to somebody else and how are you going to get paid and how are you going to manage that in a decentralized fashion, I think that definitely blockchain has a role to play there. Um, and I think another element that maybe blockchain could be valuable for here is also understanding provenance of of data. And I know that there's, and I'm not close to it at all, but um, some manufacturers use something called a digital thread to sort of track the provenance of data across their systems. But obviously, that's one of the things that blockchain can do as well because it tracks that historical record. Um, and that's, obviously important to make sure that the data that you might be integrating is legit. That it's coming from a source that you trust. So I reckon these technologies will be linked together over time, but sort of for different purposes.
Yeah, the blockchain community will be delighted that you've brought in something new like digital thread,
I bet they will.
and not just talk about the sustainability impact.
Yeah, but that's the sustainability impact of blockchains has all to do with the way that the Bitcoin blockchain is set up. It's not that the technology inherently has to be unsustainable or energy consumptive. It's just how public and anonymous do you want it to be, which determines how much computational power it requires.
Hmm.
So if I'm reading you right, we need a digital twin of the blockchain to be able to see its sustainability impact. And once we
No, now Brendan, you've gone too far. You've lost me.
that's like a Russian doll, is it? Just keeps on opening.
Yeah,
We could keep
exactly.
going and going.
Exactly. I can go like 2 layers, 3.
Yeah.
I've hit my limit. I've hit my
Yep.
limit. I'm at the little doll that doesn't open anymore.
Amy, thank you so much. This was so interesting. Really fun to talk to you, an expert in how digital twin technology is going to be adopted by the telecom industry and already is being used. So super interesting to pick your
Yeah,
brain
and
today. Thank
thanks a
you.
lot. It's great to have someone who's got a realistic perspective as well. So not
Mhm.
just saying that it's going to be adopted everywhere. So it's good that we
Yeah.
have a realistic timeline as well, and it will be a slow pace. But
Yeah.
we need to see how it builds up and how it's useful, and also where other technologies align alongside it. So thanks a lot for that, Amy, and it's great as well. I'm going to go on to Chat GTP and be able to see all of those future use cases.
Yeah, and
Yeah, that's it. You can go and look up on Chat GPT and find out what we missed today.
that's right. And thanks
I'm
for the
sure there's
reminder
nothing.
to do all of my podcast prep using ChatGPT. I've been missing
There you
out.
go. It's a starting point. It's a starting
Yeah,
point,
that's
right?
right.
But yeah, thanks for having me, guys. It's been a great pleasure, and I hope that there have been some good nuggets in there.
Yes, absolutely. Thank you so
Definitely.
much. So what do you think, Brendan? Is digital twin gonna change the way we work and live, or are we gonna just see slow, implementation of it behind the scenes?
I think it will be slow, or as Amy said, it's going to be niche.
Mm-hmm.
There's going to be very specific things. This is a technology, as we said, that's been trying to find a place for the last 10, 50 years, 10, 15, and going back to the Apollo missions as well. So I do think that iteration was just computation. This iteration is trying to find its utility in initially in the Industry 4.0 world. But what we should be able to see is more and more uses of it in the real world. So in network planning, in healthcare, in surgery, in prescriptive medicine, all of those ones seem to have a use case for it. But we just need to figure out how to develop those solutions and whether or not people will accept them and whether or not people will pay for their development.
Right. Yeah, it seems like it might not be this bright, shiny new object that we can touch and feel, but as we make, as new industries adopt this technology, it's going to make big improvements behind the scenes that are going to improve, the way we plan, for the unknown future. Yeah.
Yeah, exactly. And if we have anything such as if you're driving a car, or if I want to know that I'm walking down the street lamps work, and anything that, as Amy said, has some sort of predictive element to it that you can prevent a bad case from happening,
Hmm.
then that's going to create a better world. So we can see there is going to be lots of situations where we are going to start using this, but probably it won't be called digital twin. It'll just be called technology or AI or something else.
Right. It's going to become innate and we won't even think about it and it's just going to be there. Like many of the
Yeah.
technologies I think we've talked about so far this
You're
season.
you're just going to call a car from your phone, and it's just going to arrive, and it's going to get you to the destination exactly when you wanted it to,
I
and
can't
you're going to
wait.
say digital twin. No, it just works.
All right. Well, this was a fun one. Thanks as always. Great to catch up and great to think about the future of technology.
Thanks again, Ali. We're living in the future.
We sure are. Join us for a lively conversation on the next episode of Inflection Points with Extreme Networks' David Coleman. David discusses Wi-Fi 7, which will essentially be capable of substantially faster speeds than its predecessor, and will also provide lower latency and more stable connections in difficult environments. What does it all mean, and why is it important to the future of the infinite enterprise?
If you would like to learn more about the Office of the CTO at Extreme Networks, check out our thought leadership content at extremenetworks.com/blog. And look out for our gold Office of the CTO logo. We hope you continue to enjoy Inflection Points. Every month, new episodes will be released on Wednesdays. Subscribe wherever you get your podcasts. You can select between video and audio only streams based on your preferences.